Nobody is responding.
Good afternoon, ma'am.
So, in the last class, what we have discussed, can anybody tell me? We were discussing Frobenius method. So, can you tell me, have we discussed the first case or example of the first case or not?
Only first case, ma'am. No example.
Only first case, no example. Okay, then. So, today we'll discuss the example related to this. So, first case was when the roots of the initial equation are distinct and not differ by an integer. So, first thing is see the differential equation. Okay, that means this is of the form this. Four over okay, that means px is this and qx is this. So both px and qx are not defined at x is equals to 1 and x is equals to 0. That means both are the singular point. So when x is equals to 0 is among the singular point, always find the series solution around x is equals to 0. Right? Now x is equals to 0. Let's check whether it is regular singular or irregular singular. So let us multiply px with x. That means minus 12, 9x, 1 minus x into x. So at x is equals to 0, you will get minus 12 over 1. That means minus 12, a finite value. Now check for another factor, x square qx, this. You will get 4x, 9, 1 minus x. So at x is equals to 0, you will get 0. Again a finite value. That means x is equals to 0 is the regular singular point. So we'll find the series solution around regular singular point. That means we'll assume that y is equals to 0 to infinity x power m plus n a n is the solution of this given differential equation. Okay, if it is the solution means it would satisfy this differential equation. Now in this I have taken this I have snipped this from the B.S. Garewal book. Okay, so in B.S. Garewal book, if you can see that they have not written the summation form. If you simply expand this, that means this form they have used. Okay. For n is equals to 0, you will get a naught x power m. For n is equals to 1, a1 x power m plus 1, a2 m x power m plus 2. Okay, means you can write the expanded form here. A naught x power m, a1 x power m plus 1, and so on. So in B.S. Garewal book, they have used this, but both are same, right? Either you are writing in the summation form or in the expanded form. Both are same. Now first find dy by dx. means derivative with respect to x. For this, m a naught x power m minus 1, correct? M plus 1 a1 x power m, m plus 2 a2 x power m plus 1, and so on. Again, d2y by dx square. For this, we'll find its derivative. M minus 1, m was there, so m minus 1 a naught x power m minus 2, m plus 1 m a1 x power m minus 1, then this, right? Once you have y value, dy by dx value, d2y by dx square value, substitute all these values in the given differential equation. Okay, so we'll substitute values here. See, 9x 1 minus x here. 9x 1 minus x, value of d2y by dx square. You can see here mm minus 1 a naught x power m minus 2 plus 1m a1 x power m minus 1, and this. Then see the differential equation, minus 12 dy by dx plus 4y. So minus 12 value of dy by dx plus 4y. So before starting this method, I have told you the steps. Like first, assume that this is the series solution. Okay, then find dy by dx and d2y by dx square. Substitute back in this given differential equation. Okay, once you substitute, find the lowest power of x. Then put the lowest power coefficient as 0, equate it to 0. Find the lowest power of x, then equate to 0 the coefficient of lowest power of x, right? So when you are equating to 0, you will get a quadratic equation. Quadratic equation in terms of m. So that equation is called as the initial equation, right? So that means once we have substituted here, we'll find the lowest power of x. Okay, so let's find. So you can write this term as 9x minus 9x square. Okay, so this term will be multiplied to this. So when I'm multiplying 9x with this, you will see that, okay, I'm writing here 9m m minus 1 a naught x power m minus 1. Okay, then 9 m plus 1 m a1 x power m, 9 m plus 2 m plus 1 a2 x power m plus 1. When I'm multiplying 9x with this term, now multiply minus 9x square with this term. So I'm writing here minus, or minus outside only, 9m m minus 1 a naught x power m, because it is a square, so m, then m plus 1 9 m plus 1 m a1 x power m plus 1, then 9 m plus 2 m plus 1 a2 x power m plus 2, and so on. So instead of this one term, we have two terms, right? In first term, lowest power of x, here x power m minus 1, x power m plus 1. So lowest power is this. Okay. In second term, lowest power is this. Now in third means this. It is not multiplied by x from outside, so that means we need to search from here. So this is the lowest power. In fourth, this is the lowest power. But overall, the lowest power of x is x power m minus 1. First term, second term, third term, fourth term. Lowest power of x is x power m minus 1. Right? That means will equate to 0 the coefficient of x power m minus 1. Now search for the coefficient of x power m minus 1. I'll tell you here. Coefficient of x power m minus 1, this one. So 9m m minus 1 a naught. Here coefficient of x power m minus 1, no coefficient. Then one coefficient from here, minus 12m a naught. Right? Then no coefficient of this is equals to 0. That means we are just comparing the coefficients of x power m minus 1 both the sides. So here 0 into you can write x power m minus 1. So 0. Take a naught common. That means 9m square minus 9m minus 12m is equals to 0. Now product of two terms are 0. Either this 0 or this 0. A naught cannot be 0 because we have assumed the series a naught x power m, a1 x power m plus 1. If the starting term is 0, starting term of the series in the assumption cannot be 0 because this series starts itself from a naught. When we find some another coefficient like a2, a3, they can be 0, but a naught, first term of the series, not for every series I am talking about, the assuming series, okay, can't be 0. So a naught cannot be 0, that means this has to be 0. So 9m square then 21m is equals to 0. So take 3m common, you will get 3m minus 7 is equals to 0. So this 0 or this 0, that means now this equation is your initial equation. This is your initial equation. See the quadratic equation. So you will get two roots, m is equals to 0 and m is equals to 7 by 3. So that means first case, when the root of the initial equation are distinct and their difference means m1 minus m2 absolute value. So when we are talking about difference means we'll always see the absolute value, not the negative of that. So absolute value means in mode m1 minus m2. So you can take 0 minus 7 by 3, that means 7 by 3 only. Okay. So first case, when the roots of the initial equation are distinct and their difference is not an integer. So it is not an integer, right? It's a rational number 7 by 3 form. So first case. Now once you complete it up to here, I will first erase these things. So 0 and 7 by 3. That means m value is 0 and 7 by 3, right? So like we were doing in ordinary, when we were finding the series solution around ordinary point, we are finding the coefficients value, right? A2, A3 and so on. That means we'll have the value of y like a naught x power m, a1 x power m plus 1 and so on. So once we get these coefficients by comparing the more coefficients, you will get y in terms of m, right? And m we have two values. So first what we do here, once we get a naught, a1, a3 values, we'll substitute m is equals to 0. That is your first solution. This is the first case I'm talking about. Now put in y, put m is equals to 7, second root, 7 by 3. Okay, this is your second solution. Now c1y1 plus c2y2 is your complete solution. Okay, so this is your answer. Okay, but to find this y which does not include these coefficients, we have to compare more coefficients, more powers of x coefficients. Okay, so when you are comparing the lowest power of x, you will get the initial equation. Now second lowest power of x would be x power m, right? Then x power m plus 1, then x power m plus 2, like that. So compare the coefficient of x power m now. Then compare the coefficient of x power m plus 1. Then compare the coefficient of x power m plus 2. Okay, so let's compare to find other roots, other coefficients. Now x power m coefficient, I'm writing here. So 9x minus 9x square. So x power m coefficient means when I'm multiplying 9x with this, 9x with this, I'll get one coefficient of x power m. So I'm writing here 9 m plus 1 m a1. One coefficient I'll get when I'm multiplying 9x square with this. Okay, so minus 9 m minus 1 a0. No other coefficient I'll get from first term. Now x power m coefficient means here when minus 12 is multiplied with this. Okay, so minus 12 m plus 1 a1, right, and plus 4 a0. So these all are the coefficient of x power m. Then take a1 common between these two, take a0 common between these two, right? So when I'm taking a1 common, see here 9 m plus 1 m minus 12 m plus 1, right? Take a0 common, 4 minus 9 m minus 1, correct only, right? So this, see here m plus 1, so m plus 1 also you can take common, you will get 9m minus 12. Okay, in 9m minus 12 you can take 3 common outside, so 3a1 you will get, and here 3 4, right? So 3a1 3m minus 4 m plus 1, this is your first term, and factorize the second term also to 0. Now we have a1 and a0, so we'll always find the higher suffix value in terms of lower suffix value, right? So this 3m minus 4 that will be cancelled, take common and cancel, then means you just take common and divide whole the equation with 3m minus 4, then only it will be cancelled. Okay, 3a1 m plus 1 is equals to a0 3m plus 1. You will get, that means a1 value is a0 3m plus 1 by 3m plus 1. This. Again, now you have to compare the coefficient of x power m plus 1. You will get a2 in terms of a1. a1 we have the value here, that means a2 you will get in terms of a0. Again, comparing the coefficient of x power m plus 2, you will get a3. At least find a4, up to a4. So when you have a1 value, a2 value, a3 value, find the value, means substitute there in this. Substitute here, see all terms are in including m only. That means y is equals to a naught. I'll just keep it like this. A1 value is 3m plus 1 over 3m plus 1 a naught x power m plus 1. Then so on. Take, because every term you will get in terms of a naught, so take a naught common. So this is your y value. Now substitute first root, m is equals to 0. You will get y1. Substitute second root, 7 by 3. M value 7 by 3. You will get y2. Then c1 y1 plus c2 y2. You will get the complete solution. Okay. So c1 y1 plus c2 y2. This is when the roots of initial equation are distinct and their difference is not an integer. This is the first case. Okay. Now, second case, when roots of the initial equation are equal. Equal means like you are substituting first this a naught x power m and so on. Find dy by dx, find d2y by dx square. Substitute in the given differential equation. Then comparing the lowest coefficient of lowest power of x, you will get the initial equation, and for that initial equation you will get two roots. Both the roots are same. Okay, two roots and the roots are same. That means now once you will get y value, means once you get a naught, a1, a2, a3 like that. So when you are substituting back here the coefficients value, you will get this in terms of m only, like we did in the last example. So we'll find first solution as when we put m is equals to that first root. First root means only one root you are getting. So m1. To find second solution y2, what we do here, this y will take a partial derivative of y with respect to m. With respect to m, not with respect to x. Partial derivative end. Partial derivative means then x will be treated as constant. And then we'll substitute that root. So you will get second solution. Then c1 y1 plus c2 y2, you will get the complete solution. So this is your second case. Now let's discuss example. Example is cases written here when roots of the initial equation are equal. The complete solution is this. m1 and m1 are the roots. Like initial equation you will get in terms of this. That means m is equals to 2 and 2. Repeated roots. So first, this is the differential equation. That means px value is, divide this by 1 by x and here you will get y. So px is 1 by x and qx is 1. Okay. That means these px, qx is defined everywhere, but to be a singular point, if any of this is not satisfied, means that will be the singular point for this differential equation. So x is equals to 0 is the singular point. Now to check regular singular point, x px, you will get 1. So at x is equals to 0, analytic, and x square qx. That means you will get x square only. At x is equals to 0, it is 0. That means finite. So both are analytic. At x is equals to 0. That means x is equals to 0 is the regular singular point. Now, then assume the series, find its first derivative, second derivative. Substitute in the given differential equation. See, x into second derivative plus first derivative plus x into y. Now, lowest power of x. So it is multiplied by x. So let us just cancel from here and I'll write 1. Multiplying inside. Then only x power m plus 1, right? So here in first term, lowest power of x is x power m minus 1. Here lowest power of x is x power m minus 1. Here lowest power is m plus 1, right? That means here you will get m plus 1, m plus 2, m plus 3. So overall, lowest power of x is x power m minus 1. Now its coefficient, 1 is here, m minus 1, a naught. Okay, and from here m a naught. So no coefficient of x power m minus 1. So only this. Take a naught common. M square minus m plus m is equals to 0. A naught cannot be 0. That means this has to be 0. M square minus m. So this is your initial equation. Quadratic equation in terms of m, right? That means square. That means it should have two roots, 0 and 0. 0, 0, right? Real numbers only. If 0, 0, so what is there? But repeat it twice. That means second case. Okay. Now comparing the next coefficient of x power m coefficient to find other coefficient, these a1 or a2 or a3. So when I am comparing coefficient of x power m, one coefficient from here. So once you get initial equation, then compare the next, means second lowest power of x coefficient. So I'll show you one or two coefficients. Next is m plus 1, m a1. The next power m coefficient I will get from here, m plus 1, a1. Here no coefficient of x power m is equals to 0. That means you can take a1 common, m plus 1 common. So from here m plus only m, from here 1. That means a1 m plus 1 whole square is equals to 0. Now if I take this factor as 0, you will get f minus 1 and minus 1. But this is not true, right? Because m value is 0 and 0. And this cannot be true. So this I cannot take this as m value cannot be minus 1 and minus 1. Because already we have found m value as 0, 0. That means a1 has to be 0. Okay. So first coefficient I will get a1 as 0 here. Now comparing the coefficient of x power m plus 1. X power m plus 1 coefficient I will write here. So one coefficient I will get from here, m plus 2, m plus 1, a2. Then m plus 1 coefficient I will get from here, a2, m plus 2, right? And one coefficient I will get from here, a naught only, right? Is equals to 0. So from here, these two terms, take a2 and m plus 2 common. So m plus 1 is here, then plus 1, plus a naught is equals to 0. So m plus 2, that means a2 m plus 2 whole square minus a naught. So a2 value is minus a naught divided by m plus 2 whole square. Okay. Similarly, by comparing the coefficient of x power m plus 2, you will get a3. Okay. So see the value of a2. By comparing the coefficient of x power m plus 2, you will get a3 and a3 will be 0. A3 you will find in terms of A1, and A1 already we got as 0, so that would be 0. Now comparing the coefficient of x power m plus 3, you will get A4 in terms of A2. Then substitute A2 value, you will get in terms of A0. So this is your A4 value. Now, because this is your second case, when the roots of the initial equation are equal. First, substitute back in the assumption and then take A0 common, because every terms you are getting in terms of A0, A0, A0. That means in the final solution, you can take A0 common. Or if you want, I'll write here. Y was this: A0 x power m, A1 x power m plus 1, A2 x power m plus 2, A3 x power m plus 3, and so on. That means A0 x power m, right? A1 is 0, A2 value is in terms of A0. That means this. So I'll take minus here, A0 m plus 2 whole square and x power m plus 2. Similarly, A3 was 0. Then value of A4 is here. So I'll write A0 m plus 2 whole square, m plus 4 whole square, and x power m plus 4, and so on. See, A0 x power m, A0 x power m plus 2, A0 x power m plus 4. So you can take A0 x power m common, right? So when you are taking A0 x power m common, you will get 1 here, so 1. X square, x power m already taken common, so x square. M plus 2 whole square, x power 4 m plus 2. So in a symmetricity, you can write x power 6 also, like m plus 2 square, then m plus 2 m plus 4. In next term, it would be m plus 2 m plus 4 m plus 6 square, right? Now here solution is C1 y value at m is equals to m1 plus C2, I'll take derivative with respect to m, partial derivative, and then substituting m is equals to m1. That means to find first solution, we have to put m is equals to 0 in this. So put m is equals to 0. You will get first solution. Now to find second solution, we have to take del y over del m, the partial derivative with respect to m. Then substitute m is equals to 0. That would be your second solution. Now see, partial derivative with respect to m. That means partial derivative means other variable should be treated as constant. Consider this as first term, this as second term. So the product of two terms, right? So I write here first derivative x power m, like derivative d by dx of a power x is nothing but a power x log a, if you remember. Okay, but here a power x means x power m, don't get confused, and it is with respect to m only. That means first one differentiation, a naught is constant, so x power m log x. First one differentiation, second one same, means this whole term will be same here, plus first one same, a naught x power m same. Now differentiation with respect to m, this one, it's 0, right? With respect to m means minus x square, then minus 2 and m plus 2 power minus 3, right? Now to take derivative of this means I'm writing here del over del m, derivative of this m plus 2 power minus 2 and m plus 4 power minus 4. So again product rule, first same, second differentiation, second same, first differentiation. Okay, so it will be lengthy. Okay, now what I want to tell you, see this x power m a naught x power m and this same term is equals to y, right? So in place of this and this, I will write y log x plus this whole second term. See here, y log x and this. If you differentiate it, you will get. See here and then take common. Otherwise, leave up to here, only first term. It will take time. Now, once you get the partial derivative, put m is equals to 0. Putting m is equals to 0, that's it. You will get the second solution. Okay. Now, here putting m is equals to 0. Y is also depending on m, right? That means putting m is equals to 0, you will get y1 only. So y1 log x. Here also in y we have put it m is equals to 0. Then only we got y1. So y1 log x and this. So this is your second solution. C1 y1 plus C2 y2. That's it. So this was your second case. Now third case we'll discuss in next class, when the roots of the initial equation are distinct and their difference is not an integer. These are the lengthy questions and it will take time to solve in the exams. Even if I'll give you the simple question, then also it will take time. So try to practice other questions. You should know how to proceed and how to do, because if some question is not getting solved by you, so that you can try this method. Okay. One thing I want to tell you, please, if it is mentioned in the exam, the method, like solve this differential equation using that method, so you have to use that method. Okay. And one more thing, please work on your integration part. Work on your basics. Many students are doing like they do not have the basics idea of mathematics. I don't remember, but if I tell you, one student has written, see, like 1 plus cos x and divided by 1 plus sin x. I don't remember the name. So they have cancelled this one with this one. Is it possible, or it is expected by the students who are pursuing their technical degree in graduation, like graduation, right? BTech. So is it possible? Many things you are doing in integration while solving the integration. I don't know how can you do like this being a graduate student. Okay, but please work on your basics and integration also. Any other doubts? I'm asking any other doubts, like you have asked many doubts.
No,
Okay. Yeah, but I want to say, please don't, if you very much sure about other questions, so don't start this Frobenius method. This will take at least half an hour to solve. Don't waste your time on this. Mark your attendance, everybody. And those who have marked their attendance may leave.
Excuse me, ma'am.
Yes.
Lab like upload on 7th. I didn't do that, ma'am. So I've already like texted you on Teams also that if I can mail the DA, but I haven't
You
gotten it.
you have mailed the DA, right?
No, ma'am, no, ma'am. Actually, I have texted you on Teams that if I can mail the DA.
Your voice is not audible. I'm not able to listen your voice properly.
On 8th or 9th, itself, I texted on Teams that I can.
You, I am not even getting your voice. You send me on mail, okay? Don't write on MS Teams. I don't read that MS Teams messages. You send me on mail, okay?
Ma'am, in the lab DA, no, ma'am.
Yes.
I already sent you the screenshot of that error also.
Even I am not getting what the error you are getting. Maybe it is on the because the codes are for the old version of that MATLAB. Maybe you are getting error with that
Okay, ma'am.
because of that. Because the codes are very old, but they are working. Even I have tried. I don't know why are you getting that
I'm
error.
using the online MATLAB.
Online MATLAB means latest version of MATLAB you are using, and that
Yes.
codes are very old. Hmm.
So I'm not
So
getting the output, ma'am. The solution is not coming. So is it okay?
okay,
Solution,
you
ma'am.
no, you just upload with the errors only, no problem.
Okay,
Because
ma'am.
see, I cannot rectify here. I don't have MATLAB in this. Even if I will try these code in online, I will also get the same MATLAB, same error.
Okay, ma'am.
Okay then.